Hi there, this is a part 2 video about my USB Type-C power delivery and its alternate mode. So today in this video we are going to see about USB's history and its connector specification. So let's get started. So USB was developed in the year 1996 as a way to set up a communication between computer and its peripheral. The form factor of these USB plugs and receptacle was called as a standard size or the full size. If you could notice, we are still using the same form factor because if you see the Arduino Unos or some old-fashioned printers, there you can find these type of connectors, and still the USB connector, this Type A, is still widely used for connecting various devices to the computers and laptops. So this one is referred to as Type A plug and receptacle, and these devices are referred to as Type B plug and receptacles. And the software version which was used in the year 1996 was referred to as USB 1.0, and here the speed was very low, something like 1.56 megabits per second, and the power transmission rate was also very low, something around 100 milliamp, which is just after 2 years in the year 1998. There was another version change for the USB from version 1.0 to 1.1, and the transmission speed, the USB's protocol transmission speed was also increased from 1.56 megabits per second to 12 megabits per second. And again, after 2 years in the year 2000, USB 2.0 was launched, and it was quite revolutionary because in this phase what happened, there was almost everything changes: the form factor, the connector type, the power transmission capability, and its data speed. So in this 2.0 version we have lots of changes. So this is when USB became faster, and now the USB's transfer speed is 480 megabits per second and a power transmission of 500 milliamp. After 7 years, this is where when USB Micro was launched, and this is again more like a revolutionary because once this Micro was launched, so all the mobile handsets started using this Micro form factor for charging the device and for transferring the data. Just after a year, in the year 2008, there was another version upgrade, and we call it as USB 3.0. They introduced lots of different types of USB connectors and named it as Super Speed. Actually, the name, based on this naming convention, there was also some speed improvement, but still this was quite popular because of this super speed USB. And here if you see this normal Micro, you can see this Micro from old generation, and you can see this super speed Micro. So you can see the connector differences, and this was mostly used by external hard drives because they need a current somewhere around 1 amp, and these cables were capable of transferring up to 900 milliamps, so it was super convenient for external hard drives. And since because of this we have some improved data transmission. And here if you could see, the data transmission is 3 gigabits per second, but previously it was 480 megabits per second, but now it is 3 gigabits. You can see there's a very huge improvement in terms of speed and almost the double of the power. Previously it was 500 milliamp and now it is 900 milliamp. Again, after 5 years gap, in the year 2013, there was another USB version launched, and it was called as USB 3.1. And here the USB transmission speed was upgraded from 3 gigabits per second to 10 gigabits per second. And the power rating was also improved from 900 milliamp to 1.5 amps. And again, after a year in the year 2014, USB Type-C form factor was introduced. So this is a period when USB Type-C was introduced. Means previously I might have told that USB Micro was introduced. So Micro, it was quite famous during its time because all the modern handset devices comes with a Micro. And now since USB Type-C is launched, all the tablets and mobile phones started using this USB Type-C because it has lots of advantages. Means actually this is going to last longer when compared to other generations. But still currently this generation, this 2014 model can only support up to 3 amps, and the data transmission is 10 gigabits per second. Later, after 3 years in the year 2017, USB version 3.2 was launched, and it offered increased data transmission speed and power transmission capability. So now the data transmission speed is 20 gigabits per second and power transmission of up to 5 amps. So now we'll come to the connector specifications. We have two different types of connectors, plug and receptacle. And you can find these different types of connectors in your day-to-day life. Like our phones, cell phones, Android phones make use of the receptacle, USB Type-C receptacle, and the charger adapter, the cable which you use for charging your phone is the USB Type-C plug. So now you're clear who is receptacle and who is the plug. If you already knew about this receptacle, we have totally 4 pins for the power transmission purpose. Means totally it has 24 pins, out of which 4 of these connectors are used for transferring power. And you can also notice that these connectors, the trace length are longer than other connectors, because when the plug is inserted to the receptacle, the first mating contact, so only this power lines will mate first. So this is the sole reason for making this connectors longer, and maybe in some cases because of its larger surface area, the contact resistance might be less. So it's more like a technical stuff. So I'm not 100% sure about this, but it will help, because if you have a larger contact area, then your contact resistance should be less, and if you transmit 5 amps of power, it will be safer. We also have port 1 and 2, which are shielded differential pair for enhanced super speed data transmission, and 4 pins for USB high speed USB data transmission. So here you can see we have 2 data plus and 2 data minus, but only one is going to be used. So this 2 is for supporting the rotational of the plugs. So even though we have 2 options, but still we are using only one. That you will notice when you come to the plug side. And we also have 2 sideband signal, ESBU1 and ESBU2, and 2 configuration channels that provides many of the new features that are supported by USB Type-C. Some of the features like transferring PD data frames and configuration for the alternate modes are supported by this CC pins. So CC pins have lots of functionalities. So they will manage the alternate modes, and they will also detect the orientation logic of the USB connector, and depending upon that orientation logic, they will route the USB data and some can CC pin 1 or CC pin 2, which one should be used. So those things will be handled by these CC pins. So primarily this VCon is used to power the optional electronics which are connected with this Type-C. So here the optional electronics is the e-marker chip, which I told you in my last video. So now let's talk about the sideband pins, SBU1 and SBU2. So these are for more like a supportive kind of thing, because sometimes some protocols require some additional pins, like if you're using some display port or something, if you're transferring some high quality HD data, so there might be some additional channels might be required for other configurations. So this sideband SBU1 and SBU2 are very essential for facilitating, for supporting this alternate modes, and that's more like they'll transfer the data. They'll transfer some kind of data, but it's highly depends upon the configuration which was done by the vendor. And maybe if you could notice these products out there in the market, this 7-in-1, so definitely they'll be using this sideband signals, because we have lots of functionality within one USB send. So they will try to use the resources properly. So definitely for some purpose this sidebands will be used. So these are the specifications of the receptacle, and for plug almost pretty much we have everything the same, but here the difference is instead of 2 high-speed USB, we have only one USB line, data plus and data minus. So that's what I told you before. Even though in the receptacles we have 2 data plus and data minus pins, but still in reality we are only going to use only one USB data plus and data minus pins, because the plug only supports one, and the receptacle had 2 of these because they wanted to support for this rotationally symmetrical, because it's not like you can simply change the data plus, and you cannot swap data plus and data minus that easily. So here we have this 2 of them. So depending upon that, the configurations will be done by the software side, And I also said about we have two CC pins. So one of this CC pin will be used for this protocols configuration kind of stuff, and other CC pin will be used for VCOM, this for powering the optional electronics, whatever it is connected to the USB cable. It's more likely the e-marker chip. I hope this video was informative, and I'll also share this PPT in PDF format so that you can refer to this PPT later, and I have attached it in the description below. Thanks for watching.